In today's session, I am going to discuss biomolecules, carbohydrates topic. First, let's begin with the biomolecules introduction part. First, I am going to discuss carbohydrates. Carbohydrates. In carbohydrates, first point, definition. Carbohydrates are considered as carbohydrates are considered as carbon hydrates of carbon hydrates of carbon hydrates are carbon which is fixed into this formula, fitted into this formula, CHH2O Y times. Okay, so here one second, here some gap I had given, no need, considered, yes, come back to this. Carbohydrates are considered as hydrates of carbon which is fit into this formula, CXH2OY times. Okay, see students, some examples I am going to write here. Example 1, familiar example, that is glucose, C6H12O6. See, look into this. This is it fit into this formula or not? C6 and H2O 6 times. Is it correct or not? So O6 H2. 2 6 are 12. So fitting into this formula. This is carbohydrate. This is golden definition. Okay, next suppose sugar, C12 H22 O11. So see, this one also fitting into this formula. Look into this, C12. Yes, H2O. How many times your students? How many times your? 11 times. 11, this is 11 2s are 22. This is also fitting into this formula. These two fitting into this formula now also we consider as carbohydrates only. But some are there are some compounds which is not fit into this formula but satisfying, consider as sugar. So I'll show first example, come back to the next explanation part. See students, I'm writing here. There are some compounds. So I'm writing which are not sugars, which are not sugars but satisfies but satisfies this formula. What is this formula? CXH2O Y times. CXH2O Y times. Okay, so the best example student here I am writing. What is this? CH3 COOH. Okay, this is what? Acetic acid. It is not sugar students, but it is fitting into this formula. This is what? CX, right? C, right? C2O H2. How many times? 2 times. Yes. This is fitting into this formula. It is satisfying this formula, but it is not considered as sugar. This is one of the drawback. And another drawback, which are which are sugar, which are sugar, but not fit into this formula, but not fit into this formula. That is Rhamnose. This is one of the frequently asking questions, students. Rhamnose. Okay, what is this molecular formula, students? I am writing here C6H12O5. See, look into this one. If you take O2, this is 10. So it is not fitting into this formula. So these are the drawbacks. Okay, finally what I am saying here, there are some sugars, there are some compounds which are not sugars but satisfy this formula. There are some sugars which is not fitting into this formula but considered as sugars. So finally this is the drawback of Walden definition. So to overcome this one, now present what we are using the definition of carbohydrates. Carbohydrates, recent definition I am writing. What we are using here, recent definition. Carbohydrates are, yes, carbohydrates are polyhydroxy, carbonyl compounds, polyhydroxy carbonyl compounds. They contain C double bond OH, C double bond OH and C double bond, not and R C double bond. These compounds we call it as carbohydrates. This is a recent definition. Okay, clear? This is the introduction part of carbohydrates. Now I move on to the main topic, students. Okay, that is classification of carbohydrates. So after that I am going to discuss the structures. So what is our next topic? Classification of carbohydrates. Classification of carbohydrates based on hydrolysis. Basis on hydrolysis products. Basis on hydrolysis products. Okay, now see, first one we are discussing monosaccharides. Saccharin is nothing but sweet taste. It is derived from the saccharin. Saccharide is nothing but sweet taste. Monosaccharides. So look into this. Monosaccharides do not undergo hydrolysis. This is the starting main one. It do not, the last one. Further, it's not possible to undergo hydrolysis. Do not undergo hydrolysis. This is the final stage. Further, hydrolysis is not possible. Okay. Now, I am giving examples here, students. All monosaccharides, glucose, and next mannose, galactose, ribose, fructose, all. Okay, I am writing here examples. Glucose, next fructose, next I am writing here galactose, next ribose, mannose, all these things. Mannose. Mannose. Mannose also monosaccharide. Okay. Now come back to the second point. Second point is oligosaccharides. Oligosaccharides. Oligosaccharides means on hydrolysis it gives 2 to 10 monosaccharides. On hydrolysis gives 2 to 10 monosaccharides. Okay, they are further considered as disaccharides, trisaccharides, tetrasaccharides like this. Okay, disaccharide. See, I am writing here only. So monosaccharides also, if you want, you can write examples like this. Single units plus single units, all single units, monosaccharides. Here disaccharide is nothing but you can show like this. This one further hydrolysis, what you will get students? 2 monosaccharides. Okay, like this. Trisaccharides is nothing but 3. This one undergoing hydrolysis, what you will get? 3 monosaccharides. Okay. Next, tetra. 1, 2, 3, 4. So to understand this one, I am giving diagrammatic explanation. 1, 2, 3, 4. See, finally 2 to 10. 2 to 10 monosaccharides it will give. These are all we consider as oligosaccharides. Okay. Now, next one, polysaccharides. What is the students? Is polysaccharides. Polysaccharides is nothing but on hydrolysis gives many. Poly is nothing but many, right? Many monosaccharides. Many monosaccharides. Clear? That's it. You can show. If you need to diagram, if you want to show diagram, yes, you can show. This is poly. Poly is nothing but many. Okay, hydrolysis. 1, 2, 3, 4, 5. So you can write many. So many you will get it. Okay. This is about introduction part of the biomolecules. Now I am going to write the main structures, open chain structure of glucose, how glucose classified, how glucose identified, it, and how it is hexane structures, that and all it's there. But where students generally confusing cyclic structures, open chain structures, cyclic structures, pyranose structures, furanose structure for fructose. These are all they're confusing. There we will discuss more. Okay. Now first point students, glucose structure. I am writing glucose. And before going to that, let me give two important definitions. That is epimers, anomers, epimers. These 2 points frequently we are seeing, and reducing sugars, non-reducing sugars also. First let me list out this one, then move on to the next one. So first one, epimers. Epimers is nothing but diastereomers. Diastereomers is nothing but these are non-superimposable, non-mirror images each other. Your left hand, right hand. So these two are just ulta you can take it. Ulta you can take it. So ulta means one is like this, one is straight away, next to exactly opposite. Next you can keep it. So diastereomers is nothing but non-mirror images each other, non-superimposable. Non-mirror images each other, non-superimposable. You can write the point. Diastereomers which differ diastereomers which differ in configuration, only on only one chiral carbon, on only one chiral carbon, rest of chiral carbons, possess chiral carbon possess same configuration. Okay, now example, I am writing glucose and mannose, glucose and mannose, C2 epimers, important competitive questions. Next, glucose and galactose. Galactose we are using in lactose disaccharide time. So that's the reason I have introduced this part here. Glucose and galactose. Glucose and galactose are C4 epimers. That's it. Okay. Now, next one. Anomeric carbon also there. After writing the glucose fructose structures, I can show. In structure itself, I can show anomeric carbon. I will write the definition there. Next important thing is reducing sugars, non-reducing sugars. These two also plays important role. Let me complete first that one. Classification of carbohydrates, based on reducing nature, Okay. Now, first one I am going to write reducing sugars. These are important competitive NEET and mains examination they are asking. And while after drawing the structures, monosaccharides, disaccharides also, I will show why it is reducing. Where is anomeric carbon? Everything I can show. Reducing sugars which can reduce Tollens reagent, ammonical silver nitrate, Tollens reagent and Fehling test, cuprous chloride. So Fehling test, Tollens reagent, and next one, what is this guys? Yes, Fehling test, Fehling solution. Next one, Bendix also, Bendix solution. Okay. Now, next one, examples. Here, examples plays important role. Okay. All monosaccharides, right? All monosaccharides reducing sugars. All monosaccharides all ketos you can write if you want, or else you can take only all monosaccharides. Next one, maltose. In disaccharides only maltose and lactose reduces. Now next one, non-reducing sugars. What is this, students? Yes, non-reducing sugars. Non-reducing sugars which do not reduce, which I am using today new device, students. Handwriting it's going in somewhere sometimes. Try to understand. Voice clarity is more. That's the reason I have selected this device, which do not reduce. Tolerance test, tolerance reagent. I am writing FRTR, Fehling test, Fehling reagent. And next one, what is the, students? Bendix, Bendix reagent. Okay, examples, all polysaccharides, polysaccharides, all polysaccharides. And next one, sucrose. Most important one is sucrose, frequently asking question in competitive exams. This is the introduction part and the main important points which we are using in carbohydrates. And generally examination also they are asking this reducing, non-reducing, and epimers, anomers, and oligosaccharides. These are all we are seeing. Now I am going to the main structure, students, glucose structure. Most of the students drawing glucose structure, they are feeling little difficult. That is the reason. So we will take one best shortcut. What is that? See here how easily you can draw the structure glucose. Yes, this is head and the body like this. Okay, that's all. So what is this indicates? What is this indicates? See here, this is head. In glucose, what is the functional group? Aldehyde, students. Aldehyde means one must be hydrogen. It will be always terminal and one must be hydrogen. Right? Next, another one, students, check it. This body. This body. Here I have written bond means this is nothing but OH group. OH group. That's it. Here OH group, here OH group, here OH group, here OH group. Rest is hydrogen. Whichever this side another bond is there that I was not written here means that is hydrogen. I have written means that is OH group. That's it. And down you can write CH2OH. That's it. This is the glucose open chain structure. Can we write now, students? What is glucose molecular formula? Glucose molecular formula C6H12O6, right? So now look into this. How many carbons in our hand? Yes, 6 carbons, 4, 5, 1, 2, 3, 4, 5. Next another one, students, tell me. 6th carbon. You will write down. That's it. This down one you can write CH2OH, primary alcohol group. Here this is C double bond OH. This is chain terminating functional group head. Okay. Now here this side you can write OH, students. This side you can write OH, students, based on skeleton shortcut. And this side you can write OH. This side you can write OH. Rest all hydrogens. Rest all hydrogens. That's it. How easy it is structure, right? That's it. Clear? This is open chain structure of glucose. Open chain structure of glucose. In our NCRT textbook also, they had given how they identified 6 carbons long chain, how many primary alcohols, how many secondary alcohols, everything. It's their points. If you need explanation, those points, comments, definitely will discuss. But we generally in examination point of view, we are seeing mainly carbohydrates, monosaccharides, disaccharides structures. That's the reason those structures only confusing for everyone. That is the reason with shortcuts I am explaining. It definitely helpful, useful in your examination and preparation of biomolecules. Biomolecules, if you prepare NCRT, that is more than enough for competitive exams also. This is open chain structure. Open chain structure of glucose. Clear? That's it, students. That's it. Now, next one. After identifying the structure, some drawbacks is there. If aldehyde group is free group, it will respond for sodium bisulfite test. It will respond for what is this another test also, Bendick solutions like that. But it is not responding. Sodium bisulfite test, it is not responding. Hydroxylamine test also not giving. What is the reason? It has aldehyde group, but that is not free. That is not free. So that is the reason that tests are failed. So why it is not free? Why it is not free, students? See, it is cyclic structure. C2 and C1 and C5 cyclic structure. C1 and C5. So because of this reason only, he is not giving test for hydroxylamine. He is not giving test for sodium bisulfate. But which compound having free aldehyde group, definitely they will respond for the hydroxylamine test and sodium bisulfite. The not responding means your aldehyde group is not free, they have discovered. And where connected, this is carbon 1. Look into this. This is carbon 1 chain terminating and 2. And what about this one? 3 and 4 and 5. This is 6. Yes, here I am writing important point. 1,5 linkage. 1,5 linkage, cyclic linkage. 1,5 linkage, that too what type of linkage? Cyclic linkage. See how easily we can draw the structure. Okay, look into this, okay. I am not removing anything. Just this hydrogen will go and sit here. Oxygen, compared to carbon and oxygen, who is more electronegative? Pi electron shifts toward this side. This is minus charge. This hydrogen will go and sit here. And this oxygen linkage to this carbon to fifth carbon. Okay, how easy it is. See the structure here, students. I am drawing. Okay, to understand, I am drawing here only. See, this H as it is you can write, and second carbon no change, students. Second carbon no change, and this carbon, third carbon also no change, and the next one, fourth carbon no change. Yes, fifth carbon changes is there, and sixth carbon as it is CH2OH you can write. Okay, CH2OH. See, after that once again I will draw the structure. To understand this one I am drawing here. See, this oxygen like this oxygen linkage. That's it. This oxygen linkage, and this already oxygen is there, no? Right, and this hydrogen going and sitting here. That's it. This is cyclic structure of glucose, that to alpha form. How can you say it is alpha form? OH group is on right hand side, that is alpha form. OH group is on left hand side, that we call it as beta form. Is it clear, students? Now 3 structures I am going to write here. In this video, glucose I am explaining. Next video, fructose I will explain. Okay. Now we will draw the structure. One, 2, 3, 4, 5. This is what, students? Yes, sixth carbon, right? Okay, we'll draw the structures. First, glucose. Glucose. What is second carbon? What I said? OH this side. Third carbon, OH this side. Fourth carbon here. And fifth carbon also here. This is open chain structure. Once again, I have drawn here to understand more. Now, this is converting into, tell me, alpha form. What is alpha form? Alpha form. Can you tell alpha form? Yes, this is OH group. Just now we have taken OH group on right hand side. Rest all same. Just only connection. First carbon and OH, H, CH, CH group, OH. Yes, this oxygen connecting. That's it. This is alpha form. What about beta form? This is beta form. Just ulta. This carbon ulta. OH is on left side. H is right side. Rest all same as it is. You can write your structures. H, next OH, next OH, next H. And what about this guy? This is H. This is CH2OH. That's it. This is beta form. What is the, students? That is alpha form. That is beta form. Alpha and beta form. These two we call it as epimers. Alpha beta form we call it as epimers. Epimers. What I said to you, students? What I said to you? Epimers. Epimers is only one carbon configuration is different, rest all same. Alpha form, beta form, only one carbon, first carbon is different, remaining all are same. Clear? Now, this is I am comparing with Howard structures. Howard structures. Howard structure of glucose. Howard structure of glucose. See, students, here I am comparing with pyranose and glucose comparing with pyranose. Pyranose is nothing but very easy. Okay, I am going down. See here what I am showing here, which is in right hand side, all you can write down. Here also, which is right hand side, all you can write down. That's it. First, let me draw the pyranose structure. What is the pyranose? With including oxygen, it is 6-membered ring. It is 6-membered. 1, 1, 2, 3, 4, 5, 6. Including oxygen, it is 6-membered. You have to write. Including oxygen, 6-membered. 6-membered. Clear? That's it. Now can you try to draw this one structures alpha form, beta form? Alpha form, beta form. So that is with this we close the session. So next session I am going to explain fructose. Okay, complete. What I said above case, left hand side. What is right hand side? All you have to write down. And what is left hand side? Right top. That's it. This is alpha form. And what about the sky? You can write here beta form. Along with me, just to see, just know whatever you have written structures and draw here. These are main important points, students. After that, disaccharides, it is very easy. That's it. Okay, so alpha form. What we have taken alpha form? Alpha form OH is right hand side. Right hand side means where we will write here, students? Down. And H top. Next one. OH, you see, you can see carbon skeleton also. This is glucose skeleton also. And you can draw this one. How easy it is. Second carbon, third carbon, fourth carbon, fifth carbon. Sixth carbon, no problem. That is CH2OH, right? See, here OH is down, no? OH is right hand side, second carbon. OH is right hand side. That means you have to write down, H top. Next, here H is down, H down, OH top. Next, here OH is down, right? OH is down and H is top. And here what happens, students? This carbon, see, look into this one. It has a hydrogen. Hydrogen always you can write down, and a priority group, top priority group, CH2OH, you can write top priority group. This is cyclic linkage. Go back to the structures above cases and upso. And this is beta form. What is the difference between alpha and beta? Only one carbon. That's it. Only one carbon, right? You can draw here. This is ulta. That's it. Remaining all same, right? Yes. OH is top and H is down. Rest all same. Rest all configurations is same. OH, right? H. Next. OH, H. CH2OH, H. This is the Howard structures of glucopyranose. Glucose or glucopyranose, both are same. So with this I have completed this session, students. Next session I am going to discuss fructose structure, how easily we can write shortcut, and after that fructose we are comparing with furanose structures, and after writing monosaccharides we will move on to the disaccharides. Okay, thank you. Thanks for watching, students. Please give likes and subscribe, share our channel to your friends. Thank you, students. Thanks once again.